So let's start the presentation of the challenge itself. So I think we have all understood that delineating new lesions of MS over time is quite an important task, especially from the clinical point of view. So based on this, we have started at the end of last year to think of doing a challenge on this specific task. It's a challenge actually organized by three main partners. The first one that Anne has been talking about a little is OFCEP. So it's the French registry of MS patients, and it's gathering all over France, so around 30,000 patients, and it's gathering clinical, imaging, and biological data. So there is MRI imaging in the middle, but there is not only this, there is also clinical data and biological data to really have a complete point of view on those patients. And for them, the interest in this challenge was really to have, as Anne has mentioned, some automated methods and to evaluate them, to be able to maybe select a few of them to apply them over a large database. So we're talking in thousands of patients. So we need to have something that we're sure that works from that point of view. The second partner was France Life Imaging. So France Life Imaging is a platform that will be presented next by Michael, and the VIP subpart by Sorina. It's a platform for storage and processing of large image collections. So the France Life Imaging has been funded by ANR, so the research agency in France. And really the idea is to, among other things, support challenges, so this challenge, but maybe other challenges of segmentation or other tasks, and supporting from the storage of data to the processing of large image collection is really one of the objectives. And the third partner is what I would call us, because I'm from MPen, an INRIA team in Rennes. And so we have a long history with Christian Barrio and other people to work on MS, and we've been working on this for a long time. So MS segmentation, but also understanding the disease. And so we're very interested on one side as a participant to the challenge to see how our algorithms do, but also to evaluate in its whole, and it's one of my topics, to evaluate the state-of-the-art segmentation, in particular in MS. So that being said, the challenge objectives, the idea we had was really to evaluate state-of-the-art methods to do new lesions detection. And there are many methods that are available for detecting lesions on a single time point. There are many methods that exist already. And you could think that it's just the idea of doing new lesions detection could just be doing the segmentation on 2 time points and doing a subtraction. But actually, it's much more difficult than this. And there are many methods that have tried to, especially with the rise of deep learning, to do new lesions detection. So we thought it was the moment to try and do this evaluation. So as we mentioned already, it's a crucial marker of disease evolution, of course. And we wanted to evaluate the usability of automatic methods for detecting appearing lesions, not the ones that were present and that were growing over time, but really the ones that were not there in the first time point and that appeared in the second time point. And so we wanted also to compare the lesion detection to some experts, but we know in a single time point segmentation that there is experts variability, and we want also to quantify the experts variability in new lesion segmentation. So some side goals that we wanted to to have as well is, can we also see lesions that are not seen by experts? So this is something that I will not answer today, but this is something that we have in mind for the future, and we can discuss that at the end if you think it's interesting. It's to have methods that can tell us there is a new lesion here, the expert has not seen it, and now we ask the expert again, is there really a lesion here or not? And to see if the automatic lesions can really bring something in addition to the expert. Of course, it's not replacing, but really to help. So based on this idea, we have built a database of the challenge. So it's constituted from the sub-cohort of the OPSEC registry. And they all have a common protocol for acquisition. And we have gathered 100 MS patients from several centers and scanner vendors and models of scanners as well. So we really have a lot of variability in that, and we have 100 patients for which we have only the FLAIR images at 2 time points. They are separated from 1 to 3 years, those 2 time points. And for some centers, the reason we have chosen only FLAIR images is that in the common protocol, more and more, the T2 images and even T1 images tend to be suppressed because the acquisition time is crucial in some centers. And so we really wanted to have the image that we are sure we have, which is the FLAIR image. So in terms of pre-processing, the only pre-processing we had done for the database is to have the 2 time points registered rigidly to a middle point so that we have a resampling of each image and do not have one image that is in its raw space, not resampled. In terms of characteristics, the images vary. They have different resolutions and different voxel sizes. I've seen in some papers, some people do constating it as well. The resolution is somewhere in between 0.5 and 1.2 millimeter cubed. And then we have 15 different MRI scanners that come from different locations, so they are used differently. We have 3G scanners, 6 Philips scanners, and 6 Siemens scanners. So then what we have done is to have delineation from experts. It was a 2-step process. We had a manual delineation of the new lesions. So again, only the lesions that appeared completely from one time point to the other. The segmentation was done manually using ITK snaps, and it's been done by 4 neuroradiologists from different centers. And because we have seen in the first round of manual delineation some disputed lesions, and quite a number actually, we have had a step of validation by a senior expert neuroradiologist. And a disputed lesion is defined by a lesion that is seen by 2 or less experts, so 1 or 2 experts. If they have delineated the same lesion, then we have asked the senior expert radiologist, is it really a new lesion or is it not? And if it was a new lesion, we have considered it for the consensus. If not, we have removed it. And then the consensus has been established from that for the challenge, because we needed something to compare to. And from the validated lesions, we did a majority voting at each voxel to get the consensus. So an example data set, just to show you some images. We have the time points on the left side. So it's the first time point in the upper part and the second time point. So you may see a new lesion on the right side. It's much easier than Anne's example. So we have the 4 experts delineations. So in that case, they have seen all the new lesion. And on the right side, you have the lesion from the consensus, which is the majority voting of the 4. So this is a simple example here, but this is the basic idea for getting the consensus. Then one thing we have done afterwards is to split the challenge data into two sets, a training set and a testing set. The split has been done to respect several things. I'm not going to mention all of them, but one of them is to have all G images in the testing set so that we can test the generalizability of the methods to scanners that have not been seen in the training part. And then we have tried to have some kind of an homogeneous repartition in terms of patients, of the number of lesions between training and testing. And we wanted to have 40% of the images in the training, 60% in the testing. So this is the idea in terms of lesions of how they are split in between the training and testing sets. Now going on quickly over the challenge timeline, especially for those who have not participated. So we have released the training set on March 15. On May 25th, it was the registration deadline. So really having a team registered. We had a staggering number of 48 teams interested, which is quite crazy, to be honest. It represented 70 pipelines because we authorized teams to have several pipelines if they wanted to. So it was quite some stress for us. But we made it actually. And so we had a deadline on June 30. To have a short paper and the first pipeline integrated. So I'm not telling you how many of these 48 teams have managed it to this deadline. It's less. And the pipeline had to be integrated as a Docker sent to VIP. And then on July 16th, the final deadline for pipeline integration came in. And in the summer, we did the evaluation on our side. It's actually the VIP platform that started it. And we have analyzed the results to present them today. So now I'm going to give the floor to Michael to present France Life Imaging. And then Sorina will present the VIP platform in more details.
Okay, thanks, Olivier. So first question, can you hear me?
Yeah.
Okay.
So give you the control, if I can.
So I would try to take it over.
You can also ask for the control, but I'm going to give it to you. Okay. You should have the control normally.
Yes. Should be fine. I will give it a try. One more click.
Yeah.
Yes. Oh, okay, great. It's moving. Thanks, Olivier. So thanks, Anne and Olivier, for the talks before. So very interesting introduction from Anne to give us the reason why we are all here today. So thanks a lot for that. And thanks for the occasion to give this small talk today about the technical infrastructure that is somehow a little bit behind the challenge that we are discussing today. So the infrastructure I'm talking about, it's called, and sorry for that, it's a very long name, it's France Life Imaging. So FLI, the slides are going back, Olivier.
Already? Sorry about that.
Yes. No worries. So so it's France Life Imaging, FLI, and to be more precise for the hub, it's Information Analysis and Management, so IAM, and altogether it's FLI-IAM. So that's the name for the infrastructure. And I will explain on my next slide what it is all about with France Life Imaging and the hub included. So Michel Doja is the scientific chair of this infrastructure project. And I want to thank him as well a lot, as he has taken over the scientific chair as Christian passed away. And this was a huge task and is still one. And so thanks to Michel for that. So, and to introduce myself rapidly too. So, okay, you can read it. It's Michael Kane, my name. And I'm working as a technical project manager for FLI-IAM and as a technical manager for the Shanoir software development, which is the database to collect the images. I will explain a little bit later. So as I do not have so much time today, so I thank all these logos you see around Platform Neuro. So I will not go into detail and thank everybody because I will be too limited in time. So I will go one step further now. I lost the control. Yes, it's moving. So on this slide, I'm going to give you some more details about this quite long or this short abbreviation for this quite long word. So I will explain the missions of France Life Imaging and the mission of the Hub Information Analysis and Management. So France Life Imaging is a French infrastructure research project. And the goal is to coordinate and harmonize biomedical imaging research all over France, and to provide scientists convenient access to different imaging technologies and integrated services around, and to be as well open for collaborations with industrial partners, where I will talk about very rapidly at the end of my presentation too. So infrastructure project, and the idea behind all that was mostly that the French government could better structure the acquisition of different modalities and machines all over France, and to have a countrywide overview about the investments into different modalities and machines to have a clear idea of all that. So that's the primary goal. And it's structured into hubs. So there are 7 hubs, and 6 of the hubs are physical local nodes, so related to the hospitals in France, for example. So you have a Paris North and Paris South hub. And there is one single hub. We can, to simplify it, call it the Computer Science Hub of France Life Imaging. That's EAM. And it's distributed all over France. It's the single transversal hub or node. So before it was node, now it's hub. So that covers multiple labs all over France, as you can see on the map on the top right. So as you can read, the mission is to build an imaging infrastructure for in vivo imaging, and to respect for sure open science and fair principles, and to become somehow a service desk for research in medical imaging. And that is one goal we will work a lot in the future, is really to increase interoperability with other tools, databases from other research domains like biological or genetic databases, and to find interoperability or to search interoperability with other platforms in other countries, where it is very interesting for me to have this talk today, because it's a very international challenge day today. So I'm looking forward to have some nice exchanges on other people that might have experienced with similar platforms in other countries. So that's it for FLI-IAM. A rapid overview about the architecture we have been using for the challenge. So you have this web portal where a user can interact with the platform, can search or find its data, and can search its tools catalog and everything that is required for the users of the services of the platform. So, and you have 2 main components in the middle. So on the left, you have Shanoir, where I will go into detail right after that. And on the right, you have VIP, where Surina will give you a lot more details after my talk. So that's as it has already been introduced by Olivier. So Shanoir is able to import multiple formats and to connect from multiple hospitals to the PACS image archive servers, and to collect the images. And we have VIP, where you have worked on your Dockers for the challenge, and they have been shared with WIP, and they have been integrated in WIP and have been run on the cluster of VIP. And there is this link between Shanoir and VIP, and we will again work in the next months to automate automate as much more as we can to propose the best interaction between both platforms that we might have. So this is a big goal for us in the next months. So I'm going further. I don't know why I'm somehow losing. Has it, okay, has it moved, the slide?
Yes.
Okay, and another abbreviation. From people that might not be familiar with the French language, so it's Shanoir means black cat in French. So that is why this name, and you always see this black cat around when I'm talking about Shanoir. So you might not be surprised now knowing this, because why are they do they always have this black cat on their slides? So that's for that. And so the abbreviation is sharing neuroimaging resources, and I call it next generation for the reason as we started in 2018 to completely rebuild Shanoir from scratch with completely different tools, except we kept the primary language Java. And we finished this remake this year in April. So we have now, I call it a cloud native stack, as we are using Spring Boot 2 and Docker. And one important thing I want really to emphasize on is that historically, yes, we have this neuro in the name, but we are completely open as we are using primarily DICOM for all organs. So historically, we keep it as we are attached to our little black cat. But we could rename it and use it for different organs. So we can manage multi-center clinical and preclinical. So when I say preclinical, I'm talking about micro MRI used for animal imaging. So we support different modalities, and we are able, if well configured, to generate automatically a bits tree from the DICOMs imported. And when I talk about Shanoir, it's not only the server and the web interface, where I will show you some nice screenshots just afterwards. It's as well a desktop client. We call it Shanoir Uploader, that you can install inside the hospital environment and use it to collect the images. So about the data that are behind the challenge data that you have been using to produce this amazing results for the challenge we will see later on, and where you have been working on in the for months and have provided your Docker container. So now in our database Shanoir, in our production database, we have the data of up to 5,700 patients and 60,000 examinations, and we have the data from 26 centers all over France. So I'm going a little bit more into detail. So we are using to manage the offset cohort Shanoir Uploader that is installed in the hospitals. You can see on the French map here, and all green dots are the hospitals where we have successful ongoing Shanoir upload installation to collect the images. And the size of the dot explains the volume of the contribution of patients that have been uploaded into the centralized database. And the dark green explains where we have a direct access to the clinical PACS to search directly in the clinical PACS the images and upload them to the centralized server. So a short word on the developments we have done, especially for MSSEG-2 challenge. So as you can see on the left, it's our pretty new and from my, okay, I'm a little bit biased, a very nice homepage. And we have developed this thing you have probably all seen that have been accessing the data, this interface where you can directly download without searching further on the zip with the training data to work on your algorithms. And on the right, that is what we have been developing too. It's a mechanism of a data user agreement. So if it's configured, every challenger has to accept a data user agreement that is displayed on the bottom on the right side. And if you accept it, so it gives you access to the data and it's registered that you have been accepting the data user agreement. So this have been two developments we have been doing, especially for the challenge, and we did this for April before you provided the data. a short teaser. So we have a brand new search in Shanoir now using Apache Solr. And so just one little small word. Yes, you challenge us as we only provided you the Nifty files. You might not have any content here in the new search. It's the reason because we did not import the DICOMs as we only wanted to share the Nifties in a big file. That is why, as being a challenger, you might not have been able to use our very nice new search, but I can guarantee you it works. And we managed today 400,000 data sets for our NeuroInfo server, and we have about 20 million files on our production system. So my last slide and a short teaser. We are operating open market with INRIA, my research institute. And we have found, and you see it with big letters in the middle, it's a French abbreviation, GME FLI. So it means temporary grouping of companies. So it's the big letters in the middle. It means grouping of some companies to provide an industrial service with the software solutions I have been presenting you right now. You remember the architecture I have been shown. So there are 3 companies, Digital Analytics, Cloud Santé, and System.com, that are grouping together to form this, we can call it a company consortium. And so they are offering an industrial solution. And so if you're interested in a more industrial solution, so you can just contact me, I will make the link. And interesting point, they are a certified European health data hoster. So if you might be interested, so I can make the link. Don't hesitate to contact me. And that's it for my talk. Thank you.
Thank you, Michel. I'm going to go and give the remote control to Soy now.
Hello, everyone. Hello again. Can you hear me correctly?
Yeah.
Okay.
Yes.
Thank you very much for this amazing challenge and for the invitation today, Olivier. I'm very happy to be here with you, and I will present you very shortly, the virtual imaging platform that I'm in charge of. But before doing that, I would like to thank my colleagues, Axel Bonnet and Frederick Severnonsky, who are also working with me on VAP and who have participated in the challenge and in integrating and executing the pipelines on VAP. Can I? Yes, it works. Thank you. So, so VAP, as you probably know already, is a web portal that allows you to execute applications, scientific applications as a service. So instead of having to install them on your own computer, you can simply log into VAP on your favorite browser and then click on the application you want to execute, fill in the inputs in a form, and then launch it transparently. So in order to be able to do this, we use distributed computing resources that are offered by the European e-infrastructure EGI. As you may have seen, we have different medical imaging applications in VAP, and we continue integrating in new ones. And we currently have more than 1,300 registered users that have published 61 papers since 2011. So I go a bit quickly, but the next slide says more or less the same thing. So VAP offers scientific applications as a service. We have more than 20 applications publicly available now. Challenge pipelines are currently private. So as you know, for the challenge, we imported your pipelines in VAP, but we imported them as private. That means that only your team had access to these pipelines. So what we would like to propose is that if you are interested, we will continue supporting the pipelines in VAP on the condition they become public. So this is something we need to discuss together because it's not as simple as that. It takes quite a lot of work to continue supporting pipelines integrated into VAP. So please contact us to discuss about the future of the pipelines imported during the challenge. So VIP offers also transparent access to computing resources, as I was saying before. For example, in 2019, 2020, VIP used almost 400 CPU years provided by EGI. We also have a large community, more than 1,300 registered users. And we strongly work on providing and improving our services for open and reproducible science. How do we do that? Well, with tools such as Zenodo, DOIs, containers, and Boutique. When you provided us your pipeline to import it into VIP, we requested it to be described in a JSON format with Boutique, pointing to a container. And we also told you that we have the possibility to push it to Zenodo. You can do it directly. You can do it yourself with Boutique, but we can also do it through VIP. In the exchange, we get a DOI, which will allow you to reference your pipeline in your papers in a unique way. So very quickly, VIP and the challenge. We imported 31 pipelines during the challenge with very, very heterogeneous requirements. Some of the pipelines were very fast, 2 or 3 minutes. Some of them took up to 6 hours per patient, so pairs of images. For the memory, also, it was very, very heterogeneous, up to 64 giga of RAM. 2 of the pipelines required GPUs. Some of the containers were public, some were private, some were big, some were small. Some had issues with handling inputs and outputs, but thank you all for your reactivity and your willingness to make this happen, because at the end we managed to have all pipelines up and running on the platform. We did have a few small issues, but some of the pipelines failed on one testing image, not always the same. Maybe Olivier will say more about that later on. And sometimes for some teams, especially because of the multiple requirements we had, Dockers, JSON descriptors, and so on, it wasn't so easy. We exchanged up to 50 emails with some teams. I hope this was not too difficult for you, and I hope you're happy with the result. So thank you all for participating. And before I finish, I would also like to thank our partners, especially our EGI partners, who provided us also specific resources for the challenge, because we usually have access to normal standard computers. 3 sites from France, Czech Republic, and Slovakia provided us GPUs and more powerful machines for the challenge. So I would like to thank them, as well as our colleagues from Iraq, who also supported us with running the pipelines. So thank you very much for your attention.